Hello, I'm Mr. Precella, and today we're going to begin our college algebra course discussing something called complex numbers. And in order to do that, the first thing we're going to do is review a little bit of about square roots. This algebra course is not an intro algebra. I assume you've had some algebra before. In order for you to be registered in this course, you've got to have had some algebra before. And the first thing we're doing is discussing square roots. So I'm writing out the perfect squares. These are the numbers whose square root we know. 1, 4, 9, 16, 25. How am I getting these? Well, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 121, 12 times 12, 144. I'm sort of out of room. And then I'll just put dot, dot, dot. Okay. Now, what's significant about these perfect squares? Well, this symbol here is called a radical symbol, and normally when you see it, you read it as square root. If you had something like square root of 16, well, 16 is a perfect square. That means you can do this just with your multiplication tables, what you know about multiplying in your head. The square root of 16 is 4. Why? Because 4 times 4 is 16. That's what the square root symbol means. What number can you square to get 16? The natural question to ask is, what if you had one of these square root symbols and the number under there is not a perfect square? How would you simplify that? Something like square root of 20. Well, you've simplified stuff like this somewhere before, and here at this school we do it in intermediate algebra. That's the refresher math course before this one, Math 373, that some of you may have taken. If not, it was done in high school algebra and so forth. In fact, generally in intermediate algebra, there's a whole lot of simplifying with radicals done. Cube roots, fourth roots, and so forth. Primarily in this course, we're just going to be seeing square roots. And the way I'll simplify square root, it might be how your previous teachers did it, or it might not. Maybe you've done this using a factor tree. That's not how I'll do it. The way I'll do it is I'll ask myself, let's rewrite 20 as a product using a number, one of these perfect squares. What numbers here, which one of these numbers divides evenly into 20? Well, 4. 4 times 5, 4 times 5 is 20. Follow the colors. That red square root of 4 we could write as 2 square root of 5. Okay? So to simplify a square root, if the number under here is not a perfect square, you write it as this is how I do it. If you remember drawing out factor trees and want to do it that way, that's okay. Suppose we had something like the square root of 700. Well, quite a few of these perfect squares would divide evenly into 700, but generally if you can spot the biggest one, that's going to simplify it faster. At 700, I would think of as 100 times what? Well, times 7. Sometimes students say, well, what about 350 times 2? No, it's got to use a number whose perfect square you know. Or whose square root you know. So the square root of 100 would be, follow the colors, that red square root of 100 is a 10, square root of 7. Now, I'm going to draw a red X because what I'm about to write is a common wrong answer. This is wrong, what I'm about to write here. Sometimes students will see things like this: the square root of negative 16, and when they then try to say, oh, well, then that's a negative 4, but that's wrong. Can y'all see the red X through it? Why is that wrong? Could y'all tell me? Well, negative 4 times negative 4 is not a negative 16, it's a positive 16. In general, the square root of a negative number is not defined as a real number. It'll be clear in a moment why I'm using this, saying it's not defined as a real number. If you sometimes, let's see, pulled out a calculator. This is like the calculators I'll be using during class. It might be hard to see this. Let me see, but if I move it over here, sometimes on this side it looks better. If I turn this on, if I punched in square root of negative 16, to punch in a square root on this one, I go second square root, negative 16. What I want you to do is see what it tells you. It says error, that's the ERR, non-real answer. And then I have a choice to either quit this or go and correct it. To go and correct it, I would need to remove that minus. Non-real answer. Well, we are about to define, all your life you've heard about, all your mathematical life, you've heard your teachers talking about real numbers, real numbers. That sort of gives you the idea that maybe there's something that's not a real number, and there is. There's something called an imaginary number. What we're going to say is the square root, now this is something new, by that I mean I'm assuming you haven't seen this before. The square root of a negative number is an imaginary number, and we're going to denote imaginary numbers with the lowercase letter I. With that, having said that, if we had something like the square root of negative 25, the way you simplify that is to say, okay, the square root of 25 is 5, then stick an I on it. If we had something like the square root of negative 100, what would that be? Well, the square root of 100 is 10. Because you're taking the square root of a negative, put an I. That's an imaginary number. So at this point, you can really define a real number as saying, okay, a real number is any number that's not an imaginary number. So things like square root of 17, square root of 25, square root of 4597, the square root of 3/7. All of these numbers I've written here are real numbers. Okay? Real numbers are not imaginary numbers. And imaginary numbers are the square roots of negatives. So let's do this first problem. What I've done is I've printed out my Math Lab homework, and we're just going to be working it out here. And then some of you will print out your homework throughout the semester, and if you do that, then you can work it out. Then you've got to go to a computer and punch in your answers, okay? And so what I'll be doing during the face-to-face classes, I'll be actually punching in the answers, but for these videos, I can't really show you me punching them in. I'm just going to be working out the problem. So if you're taking this as an online class and you have trouble punching this in, you might want to go and go to the Math Learning Center and get a tutor there to help you log into my Math Lab if you're having trouble with it. Okay? Now, let's see, the square root of negative 81. Here's our first homework problem this semester. Well, the square root of 81, that's a perfect square. The square root of 81 is 9. Is that the first time that's happened this semester? The lights cut off in this room if there's not a lot of motion, so that's why it went dark all of a sudden. The square root of 9, excuse me, the 81 is 9. Since it's the square root of a negative, we put an I. So you type in 9I. Now, what about this next one? The square root of negative 147. Well, 147 is not one of the perfect squares, so it's a matter of figuring out, well, which one of these will divide into it. Okay, what's the biggest one of these numbers? Well, an even number can't divide into an odd number like that. So 4, I don't need to try. What about 9? 147, 147 divided by 9? Nope. 147 not divided by 16. Sort of going through trying to figure out which one of these numbers divides into 147. I'm going to try to write it as a product, the way I did this stuff here. Okay, square root of negative 147. Oops. Trying to make this look a little better. So, with a little bit of effort, okay, just sort of punching into your calculator, which one of these, what about 49? What's 147 divided by 49? 3. 49 times 3 would give me 147. So if I think of this as the square root of 49 times 3. Now, because of this minus sign under the square root, there's going to be an imaginary number. I'll just stick this green circled I. It's the reason I have that green I there. Now, to simplify, the one I can simplify is that square root of 49. I could write that as 7. And then we still have that square root of 3. Now, where to put the I? It's customary, if you have just an integer and a square root, that you put the I right in between them. 7I square root of 3. But if you wanted to put the I in front of the 7, my math lab will take that. Or if you want to put it at the end of the fraction, just make sure it doesn't look like that it's not under the square root symbol. The I should not be under the square root symbol when you type this. Now, a little terminology. The name of this lesson is complex numbers. So let me actually define what the heck we mean by a complex number. Okay? A complex number is in the form A plus B I, where A and B are both real numbers. An example of a complex number would be something like 2 plus 3i, or 4 minus 7i. Notice you can't actually add the 2 and 3, because when we treat this I as if it were a variable, what's the little phrase you say? Well, those aren't like terms. You can't add the 2 and the 3 because there's not an I on the 2. Like here, you can't subtract the 4 and 7 because there's not an I on the 4. Those aren't like terms. So if you have a real number together with an imaginary number, you can't really add them or combine them together. All you can do is write them in that form. We could go further and say that every real number could be written as a complex number. You could take any number you want. Let's say your favorite number is 28. Oops, 28. And you could write that as a complex number by writing plus 0i. Okay. So we could say formally, the real numbers are a subset of the complex numbers. Every real number is a complex number. But for ours, we're getting, maybe for our purposes, we're getting too involved there. Here, number 3 says, write this in standard form. You might be wondering, what the heck is standard form? Well, it's going to be in the form a plus bi. This is going to reduce to a complex number. So how do we go about this? Well, first thing we need to do is simplify the square root of negative 54. So I'm reducing the square root of negative 54. Well, first thing I'd ask is there going to be an I here? And yes, the square root of a negative number is an imaginary. Now, how good are you at that multiplication tables? Which perfect square here divides into 54? You thinking 9 times 6? 9 times 6, does that give us 54? So, how would this reduce? We have the I. The square root of 9 is 3. The square root of 6, well, we can't reduce that. There's no perfect square that divides into it. So this circled square root of negative 54, we could write as I3 square root of 6, or I'm going to write it as 3i square root of 6. Again, it's customary to put the I in the middle there. So rewriting the problem, I have a negative 6, then a plus, all of this stuff right here. 3i square root of 6 all over 3. Now, at this point, some students will go overboard or go too quickly and just cancel the 3's, and when you punch it into my math lab, it's going to say error, or you got it wrong or something. Well, in order to reduce this, both of these numbers here are over 3. So if you just have one number in the bottom, you don't just cancel it with one of these, you've got to separate it. That's what these little marks here that I'm writing mean. So we'd have negative 6 over 3 plus 3i square root of 6 over 3. How would that reduce? To negative 2 plus I square root of 6. And then just to make sure you have the hang of these, I have another one like that for us to do. Ooh, this one might take a while to reduce it. That negative 432. Well, let me get my calculator out. And what I'm going to do is try to figure out how to reduce the square root of negative 32. Well, first of all, will there be an I in it? Well, yes. Okay? Because of that negative under the square root. So I'm reducing the square root of negative 432. Because of this blue negative here, there's going to be a blue I. And then it's just a matter of figuring out what's the biggest one of these perfect squares that divides evenly into 432. I'm so sort of reluctant to say you just start. Okay, 432 divided by 4. Well, that divides evenly into it, 108. 432 divided by 9. 432 divided by 16. It's a matter of finding the biggest one. So wow, there's a lot of these perfect squares that divide evenly. The biggest one would be, does 144 divide into it? Let's see. Yeah, 144 times 3 is 432. Ooh, can y'all see that? So 144 times 3. And we know the square root of 144. The square root of 144 is what? 12. So this one, I'm going to rewrite this 432 as 144 times 3. And all of that reduces just to, we have the blue eye. The purple 144 is a purple what? 12. And then square root of 3. So now it's similar to this one over here. We have the 8 minus, in place of that square root of negative 432, I'm going to put the imaginary number 12i square root of 3 all over 4. You don't just divide one of these numbers by 4, you divide both of them. Let me do that. So the 8 over 4, 8 divided by 4 is 2, minus what? The 4 goes into the 12 3 times, so 3i square root of 3. And when you're typing these in My Math Lab, by the way, throughout My Math Lab, never type a space key when you're typing answers. At no time this semester will you ever need to hit a space key. It'll space the stuff correctly. For the I, just use a lowercase I. Also, never type answers with capital letters in My Math Lab. And then there'll be a little hot button on the left with the square root key. In case you're thinking, I don't know how to type a square root key. There'll be one that you just move the mouse to and click it, and it'll put the square root key there for you, okay? Let's see. Oh, one more of these, just to make sure you get the hang of it. And then we'll take a break. Oh, okay, at least the number's not real large. Square root of negative 20. To simplify that, will there be an imaginary number? Oh yeah, because of this black negative, we have a black I for imaginary. This is one I don't think we need to use a calculator on in order to figure out which perfect square divides evenly into it. 4 times 5 would give us 20, right? Look at how, sometimes this is how people like to do it. Instead of writing 2 square root symbols, just write it like that. And then say, okay, we have the I. The square root of 4 is a pink 2. And then square root of 5. So we have negative 8 plus, I'd write that as 2i square root of 5, all over 24. Well, can I just put, I'm going to, remember you separate it, so I'm just going to sort of skip a step and just put each of them over 24. And how will this reduce? The 8 over 24 reduces to 1/3, so it's a negative 1/3 plus 2 goes into 24 12 times. So I think I'm going to write it like this. Square root of 5 over 12, and just put the I out beside it. That's a standard form for writing it, but there's sure no reason why you couldn't put the I just up and top. I square root of 5 all over 12. They're pretty, My Math Lab would take either one. you to put the I out beside this like it's a fraction. To punch in fractions, you either hit the little slash on the keyboard, or there'll be a little hot button on the left where you can punch in your fractions. Okay? So I'm going to take a break now. It's going to be important that as soon as, so I'm taking a break now. It might be a good idea for you to go ahead and pull up the actual homework and work these first 5 problems like this. Your homework problems will be similar to these. Okay? So maybe work these 5 homework problems that are like this. Okay? And what we're about to start after the break, we're going to be adding, subtracting, multiplying, and dividing complex numbers, which sounds much harder than it is. If you remember how to add, subtract, multiply, divide polynomials, then you're going to have no trouble with this. And let me tell you, in case you don't know what I just said, you do know how to, because you're in here. You've added, subtracted, multiplied polynomials in all of your previous algebra classes. Okay? So we will pick up in a little bit after the break. Okay? So use this time maybe to get started on the homework, or if you want to go ahead and just move on to the next video. Okay? Thank you.